The Black Death, the plague. When you hear those, it elicits pictures in our mind of mass death. Mass death that spread from Asia, Central Asia, the Middle East, up through Europe, down through Africa. Great pandemics that wiped out large percentages of the world population. 6th century AD, what historians attribute to one of the things that truly put Western world, basically Europe, into the Dark Ages was the plague. The plague came in and wiped out 100 million people. Entire towns, villages, here today, dead and gone by next week. So the scope of these pandemics at this time were great. Well, nowadays in our modern medicine, when we look at the plague, we find that the plague presents in numerous forms. There is the pneumonic plague, a respiratory disease, that'll be discussed in chapter 19. There is the bubonic plague. Bubonic plague, as we're going to see in this lecture, characterized by large lumps under the jaw, armpits, groin. They call these large lumps buboes. We now know these are swelled up, pus and bacteria filled lymph nodes. And then the septicemic plague. Here, remember, septicemia means that the plague, the bacteria causing plague, is now growing in the blood. The disease starts with a flea bite. The flea is the biological vector for the bacteria. Okay, flea goes, bites somebody, a person or an animal that has the plague, is carrying the plague, is a carrier or is sick with the plague if it's a human. And it grows in their mouth, their gut. They go in for their next blood meal, spit in saliva with anticoagulants and the bacteria. The bacteria gets into the new patient, travels to the nearest lymphatic vessels. Because it's not getting into the blood, it's in the tissues. Remember, the tissues get drained by the lymphatic system. So it's drained away to the nearest lymph node. There at the lymph node, it'll start to grow. The bacteria will start to increase in numbers. Hence, you get the swelling of the lymph nodes, the buboes. Can also end up with the bacteria, because of the swollen buboes, the inflammation, you can get some tissue degradation and opening up of nearby capillary beds, allowing the bacteria to go from the bubo into the bloodstream, and then you get septicemia. Incubation period, from the moment of bite to the beginning of symptoms, 2 to 8 days. Yeah, 2 to 8 days. There are accounts, from medieval accounts, people getting exposed on Monday and dead and buried by Sunday. Okay. After the incubation period, get fever, chills, nausea, headache, weakness, and then after a day or so of that, you start to get the buboes showing. Mortality rates in modern world, even with treatment, depending upon where you're at in the world and what treatments can be offered, 15% mortality rate. Okay, that is still scary high. Pneumonic means you breathed in somebody else's respiratory secretions. So you hear the plague bacteria is being transmitted via respiratory route, or if it's the bite in the bubonic, as I said in the last slide, it can progress to you end up with septicemia. Once the bacteria are in the blood, you're going to see that patients are going to start to develop issues with blood flow, leading to hemorrhaging and or necrosis. Okay, the presence of the bacteria and some of its metabolic waste and things like that are going to start to introduce coagulation, clotting of the blood in the capillary beds. Clotting of the blood is going to lead to stop of blood flow in a given area. It's going to start to pool. You're going to get the subcutaneous hemorrhaging because the capillary beds can't handle that increased back pressure. So you're going to get what they refer to as purpura. Nice red splotches. That red splotch, blood flows in, nothing flows out. The cells there are going to start to be bathed in their own waste. Those cells can and will start to die. Cells just beyond that blockage that are now impeded, are suffering from impeded blood flow, will also start to die. So you're going to get necrosis of the cells, necrosis of the tissue, leading to gangrene. Okay? Necrotic tissue, you excise that out, sew it up. Good chance that tissue, that organ can be saved. Once it goes to gangrene, well, you just have to be more liberal in how much you start cutting out. Once the plague hits this point, even with treatment, once you start to see the purpura, the coagulation, necrosis, and gangrene, even with surgical intervention, mortality rate jump from the 15% to 30 to 50%. Untreated, 100% fatal. It's this swelling of the buboes, the area around the buboes turning black, the fingers, the extremities turning black because of the lack of blood flow to them. That's where the term Black Death came from. So you would see clinically, there are accounts from medieval times where, people keeping track of spread, keeping track of symptoms. The nose, the lips would turn black, the fingers would black. The big swellings, the buboes would turn black. Some of them would start to form abscesses, large abscesses. And when I say swelling, some of these buboes could swell to be about the size of a plum. Think easily the size of a golf ball. And sometimes even bigger. Our causative agent here is what is a bacteria known as Yersinia pestis. Okay, it's a small gram-negative bacilli. You look to the right there, the pictures of its staining. It has a characteristic gram stain appearance. The textbook and some other textbooks refer to this as a safety pin. Look, some reason when it stains looking like that. The big orange you see are cells that were aspirated. It's this right here. This, if I can get it there. That is one Yersinia pestis cell, and it takes on that characteristic gram stain appearance. Now, that's not a gram stain there. That, I'm not sure which stain that is. I'd have to look it up. Because remember, gram negative means it's going to stain red. This is purple, so they probably just used crystal violet. So if you're looking at the colors and wondering why the color's not correct for it, even though I keep saying gram stain, that's why. The pathogenesis, the pathogenicity of this bacteria, Yersinia pestis, is extremely high. The numbers that they have calculated that you would need, the infectious dose, 3 to up to 50. Okay, that's a pretty big range there, 10-fold range. But it's, which ones are you talking? Are you talking respiratory? Are you talking bubonic? Are you talking septicemia? But the numbers, any way you look at it, the numbers are still quite small. That's how pathogenic this microbe can be. So I talked about the transmission. Generally, it's going to be an infected flea. Okay, fleas rarely going to jump human to human. There's a lot of times fleas going to take its meal, jump off, land on a rat, land on an animal of some sort, another mammal. It's going to feed on them. It's going to jump to another human, bite them. So you'll see that, during the medieval period, they initially thought it was the cats that were spreading this. So they went through and they killed all the cats. Well, it turns out that the fleas were riding on the rats. The rat population that was kept in check by all the cats. And when they killed the cats, the rat population skyrocketed. And that means more things to carry around, more things to sustain the fleas between the times they were going in and, biting humans. Here and nowadays, in the southwest U.S., Yersinia pestis is a bit of a problem. Instead of rats, it's groundhogs, or sorry, not groundhog, prairie dogs. Groundhogs are the issue. Fleas live on them. They come into close proximity of humans. Fleas jump off. Fleas jump on us. There you go. Yersinia pestis, the plague, is still a problem around the world. We haven't fought this one off. So it's endemic in certain areas. People are just going to get exposed. It is hard to get. We don't live in close proximity as they used to with rodents. So our exposure to fleas coming off of rodents has been greatly decreased. So put out those mouse traps.